Hi everyone, welcome to my video. In this video, I'm gonna introduce the MDOTBarrier program, which I was developed for the calculation of the barrier capacity after the fascia deterioration takes place. So although the research team was composed of these members, I was the only one to develop develop this program. So let it give a couple seconds to pop up the application window. Meanwhile, I'm gonna give information related to the how the program was developed. This program was developed with the help of the funding provided by Michigan Department of Transportation. The program was developed in the MATLAB App Designer module between the years 2021 and 2023. So this program is intended to use for the computation of bridge deck fascia capacity after the deterioration takes place, whether or not the posting or some other precautions should be taken accordingly. So the program includes like a total of 5 tabs, as can be seen here. The introduction tab requires general information about the project. So I will give detail about this project data loading in the upcoming minutes. So throughout the program, you will see the I buttons everywhere. Actually, these I buttons are provided for providing information about the program for specific purposes. For example, let's start with the input tabs. So depending, for example, there's an I button here. So I'm requesting parameters like x1, x2, x3, and x4 for this, for example. And everything is described here, what x1 means, x2 means, so on and so forth. So you need to provide all this information. Similarly, A1, A2, A3. So all these information are requested as shown here. So this is for these two are related for the geometrical properties for the reinforcement and for the barrier and deck. And the third table over here is provided for the purpose of obtention of the inputs related to the reinforcement. So barrier distributed reinforcement, etc. All of them are again explained here what they are and how they need to be entered and etc. Grade in like uncoated or epoxy coated side spacing and etc. All of them are explained in these tabs. And after that, actually, you will need to select the barrier test level. These TL levels are described in AASHTO LRFD. So TL4 is for the highways typically. So these are all explained here. Depending on your purpose, you will select one. And barrier deck connection type, there are 3 connection types are listed here. And these are also explained here what each means, depending on the AASHTO LRFD 2020. By the way, like throughout the program, actually, we always use the formulations given in the AASHTO LRFD as necessary. So deterioration thickness and deterioration length, these are the 2 main inputs that we require to be able to perform the analysis after deterioration takes place. The deterioration thickness is the thickness in which the deterioration takes place with perpendicular to the direction of the traffic, as can be seen here. You need to provide an average value, although like it may not be that severe, whatever it is. So you need to provide an average deterioration thickness. Similarly, for the deterioration length, so you need to provide an average deterioration length to be able to calculate the deteriorated fascia capacity. So deck concrete type and barrier concrete types are also requested, like normal weight, lightweight, and concrete composite strengths are all provided here. So this is the only input tab that you need to provide. So after you provide all these inputs, actually the program will do the rest. I'm not going to provide the inputs right now. Instead, I already did an example analysis and this will be loaded right now. So this button allows you to recover the data that you have already done before. So After you select your input math file, which I will show you how to obtain it at the end of analysis, actually the previous analysis data will be restored as shown here. So inputs were successfully provided. So these are all the inputs that actually related to the project, a real project in MDOT4 S11 project, like type TL4 requirement is selected, type 2 barrier deconnection type is selected. Deterioration thickness is provided 6.5 inch, which is approximately like 15 centimeters, which is quite a lot. So this might be an exaggeration, just for example purposes. You can enter whatever you want. Deterioration length is 180 inches. So approximately like converted to the meters currently. So after you provide all inputs, actually you provide a calculate button. So the analysis will start immediately, and it will take approximately like 20 seconds or so to complete the analysis. So undeteriorated part was done, and now the deteriorated capacity was done, and analysis is about to finish, completed successfully. It's around 20 seconds or so, as I said. So you will click on results summary. So in the results summary, there are 3 main checks is listed in this table actually. Like if you click on this I button, you will see what each means. So I'm trying to explain what they are. And if you see green here, actually it's okay. But if you see in red, it means that it's not okay. So for example, the barrier transverse capacity RB is not okay. The demand based on TL4 requirement is 54 kips, but yeah, original capacity was 76.7 kips, but after deterioration, it decreased to 50 kips or so. So 50 is smaller than 54, which means that actually your deterioration is enough to not met the TL4 requirements. So either you need to post a bridge, or you need to repair the fascia, or you need to decrease the requirement to TL3 or so and so forth. For example, in TL3, what was the barrier transverse capacity requirement? So for the TL3, for example, it's not listed here. You might consult AASHTO LRFD for the requirements, or the MDOT report, or MDOT report actually. So shear transfers from barrier to deck. So this is the check number 2. Check number 1 is the barrier capacity, which is this one. Check number 2 is the interface shear capacity between barrier and deck. This is okay. And 3 is the actually flexural capacity of the deck at the intersection of deck barrier reinforcement. So at this location, actually, the impact force needs to be transferred to the deck successfully. It seems like this is okay too. So this is the summary of the analysis results, actually, nothing more fancy. So these 2 tabs actually is detailed analysis results, which may be needed for like curiosity. For example, what will be my flexural resistance of my barrier about vertical axis, horizontal axis, transverse resistance of the barrier. So this is original design. As can be seen, original design is okay. So you see there are some development leg checked. Some of them are red, which means that actually it's not the required development leg has not been met. That doesn't mean that actual design is not okay, since it is taken into account by reducing the area of the reinforcement appropriately. Actually, the lack of development link will be taken into account. So if you see red here, it doesn't mean that your design is not okay. Your design might be okay, but it's taken into account. I just wanted to say this to you. So if you, other than that, for example, flexural moment capacity with introduction 22.6, which is okay actually. So all of these actually, what they are, like moment transfer from barrier to deck, what is meant and how it's calculated, are briefly explained here, and full explanation is given in the MDOT report, which will be published at the end of 2023, hopefully, or sometime in the beginning of 2024. Project has not been finished yet. So like all these I buttons provides detailed information about the selected type of analysis and etc. After deterioration, of course, like you might see some more reds. For example, here the capacity is not sufficient. So similar to the original design, but some more detailed analysis results and etc. are all provided here. So that was a summary for the MDOTBarrier program. Again, it might be useful to calculate the analysis results for the deteriorated bridge deck fascias, whether or not it will take the required TL requirements or not. So thanks for watching this video. Bye-bye.